Question 39. The temperature T of a given cup of hot chocolate after it has been cooling for T minutes can best be molded by the function below, where T note is the temperature of the room and K is a constant. Also, it could also be T note of 0 or T sub 0. That means over here, let me write out the equation they wrote for us. The equation is ln, that means the natural log. Natural log is E. They don't write that, they just write ln, the natural log of 150 minus 68. So they don't write that down. They write that down. They write down the natural log, that's ln, of t minus t sub 0, or t note, is equal to negative k lowercase t plus 4.718. Now, let's plug into the equation what we know, what they tell us, before we read any further. The temperature T of a given cup of hot chocolate after it has been cooling for T minutes can best be molded into the equation. So we know the first T is the temperature of the hot chocolate. The T sub 0 is the temperature of the room. ln is natural log, which is E, or 2.7 something. It's equal to negative K. K is a constant. And we add 4.718. So the first part of the question is, a cup of hot chocolate is placed in a room that has a temperature of 68. So we said T sub 0 is the temperature in the room. So that's 68 degrees. So ln is a natural log of T minus T sub 0, and T sub 0, or T note, is what is it called? T sub 0, we said the temperature is 68 degrees. Now, after 3 minutes, so we know what K is. K is a constant, and the small t is the amount of minutes. So after 3 minutes, so this over here will be 3 times negative K so natural log of T minus T sub 0, and T sub 0 is 68 degrees, is equal to negative K times the amount of minutes, which is 3 minutes, plus 4.718. You have to do this question, the last question on the region. The reason why it's 6 points is because you have to put a lot of work and a lot of points connected to it. First write down the scrap paper, the whole equation, and write down all the parts, and then rewrite it onto this page. So anyways, it says, a hot cup of chocolate is placed in a room that has a temperature of 68 degrees. So that's T sub 0, 68 degrees. After 3 minutes, that's negative K times lowercase t. The temperature of the hot chocolate is 150 degrees. So we said the first T, if you read the beginning of the question, it says, in question 39, January 2011, Algebra 2 Trig, question 39 says the temperature T of a given hot cup of chocolate after it has been cooling for T minutes. So after it has been cooling, so we said after it has been cooling for T minutes, that's the 3 minutes, the temperature we just said is 150 degrees. So we're going to erase the T. I'm going to erase this in order to make some room. So it's 150 degrees times, it's not times, it's a natural log of 150 minus 68 is equal to negative k times 3 plus 4.718. So let's put this all together. We use our calculator for questions like this. So this becomes the natural log ln of, so you do ln on your calculator. If you see on the TI-83 and 84s, on the bottom left is the on sign, above is the SDO sign, above that is the ln. So you hit the ln once, and you do 150 minus 68, close parentheses, is equal to, so this thing is equal to 4.406719, and we'll stop over here because it's 192, and they don't usually tell us to go that far. They tell us compute the value to the nearest thousandth. So to the nearest thousandth, so this 4 is in the ones place, this 4 after the down the tenth place, the 0 is in the hundredths place, the 6 is in the thousandths place, and the S just to the thousandths place. I already went to the 10,000th place, the hundredths, and the millionths place. So I'm going to round off from the millionths to the 100,000th place. 19 becomes 2, because it rounds up. And that's equal to negative k times 3 plus 4.718. Now, we want to get k by itself. Now it became a regular algebraic question that you have in 9th grade. So to get negative k by itself and then afterwards to turn to k, we do the opposite of PEMDAS, of parentheses first and exponents. We do addition subtraction first instead of doing it last. First you do PEMDAS, but when you break apart our equation, you do PEMDAS backwards. You do addition subtraction first. Subtract 4.718 from both sides. Subtract 4.718 from both sides. So this number over here minus 4.718 equals negative k is equal to negative 0.31128. Now, so what is k equal? And it's times 3. It's equal to negative k times 3. Remember, we just did addition subtraction first. Now we have to get rid of the 3. It's negative k times 3. So let's get rid of the negative 3 at the same time. First of all, let's continue this up here. First we'll divide both sides by negative 3. Because it's negative k times 3 or negative 3 times k, it doesn't make a difference. It will equal to negative 3k or negative k3. So divide both sides by negative 3, because first you're going to have to divide both sides by 3, and then you're going to have to multiply or divide both sides by negative 1. So just divide both sides by negative 3 to make the negative k into positive and to get rid of the multiplication of 3. So 3 divided by 3 is 1. It's negative 3 divided by negative 3, takes the negative and gets rid of it, makes it a positive. And then this number divided by 3 is equal to k is equal to 0.1376, and they ask you to compute the value of k to the nearest thousandth. So tens, hundred, thousands, so you round it up. Becomes, get rid of the 6, because 5 and up you round it up. The answer is 0.1376. Question 39. The temperature T of a given cup of hot chocolate after it has been cooling for T minutes can best be molded by the function below, where T sub 0, or some people call it T naught, is the temperature of the room and K is a constant. And they give you the formula of the natural log of T minus T naught is equal to negative K times T plus 4.718. It sounds like it's very difficult, but let's see what information they give us. A hot cup of chocolate is placed in a room that has a temperature of 68 degrees, and we said that T naught is the temperature in the room. So that's 68 degrees. Instead of T naught, put in 68 degrees. And after 3 minutes, so we said lowercase t is the minutes, so put in, for lowercase t, put in 3. The temperature of the hot chocolate is 150 degrees, and we said in the beginning of the question that T is the temperature of the hot chocolate after it's been cooling for T minutes. So after T minutes, or after 3 minutes, it's 150 degrees. Now, we have the whole equation. We could solve everything because the only unknown is a negative K. So the question is, compute the value of K to the nearest thousand. Only an algebraic solution can receive full credit. So you have the natural log of 150 minus 68. So you take out your calculator. You go up on the bottom left side. You see it says on button. Go up 1, 2. Above the on button is SDO. Above that is LN. Press LN of 150 minus 68, close parentheses, enter, is equal to 4.406719, and I rounded it up to 2. Because we only need to the thousands, I could have just rounded the 7 up to 0.4067 to 0.407. But for now, I'm just doing it like this. Now, so now we know what the left side is. 4.40672. The right side is equal to negative K times 3 plus 4.718. Subtract from both sides 4.718. You get the left side is equal to negative, because 4 minus 4 is 0. 0.40672 minus 0.718 is equal to 0.31128, is equal to negative K times 3. Get rid of the negative and the 3. Divide both sides by negative 3. You get K is equal to 0.10376, and it says rounded to the nearest thousand. To the nearest thousand, K is equal to 0.104. That's part 1 of question 39.